so I think there might be a race in the Milky Way. Holy shit, this is amazing. We will learn a lot in the next 10 years. 7 trillion miles from Earth, the James Webb Telescope has made a discovery that has never been made before. City lights in space. This amazing discovery has sparked a wave of interest in the possibility of extraterrestrial life. The telescope focused on Proxima Centauri b, the closest planet to Earth, and saw a strange bright light coming from it. What is responsible for these city lights on Proxima Centauri b? Does this mean there is life beyond our planet? Join us to learn how to identify these amazing objects in space using the James Webb Telescope. For many years, scientists and the general public have searched for possible worlds outside the solar system. Evidence to support this space fantasy has been welcomed over time. Recently, the scientific community was shocked when strong evidence of life in space was discovered by the James Webb Space Telescope as it searched the space and provided important information to the Earth. The James Webb Space Telescope discovered the city lights from the exoplanet Proxima Centauri b. As the name suggests, the city lights appeared to illuminate a distant city. The possibility of an alien city on this star surprised scientists. They are all confused because this is what they have all been waiting for, that if this turns out to be true, as everyone thinks it is, it means that there are intelligent life forms organizing civilizations foreign to what humans know in outer space. And we are only just discovering it. Peering into the city lights that are located 7 trillion miles from Earth, NASA engineers can't help but wonder how long these lights have shone in space, waiting for humans to grow the required technology to detect them. David Kipping, an astronomer from Columbia University, describes the Proxima b exoplanet, where the city lights were found, as tricky. He said so because this star system nearest to us has varied heating patterns that aren't similar to other planets. The usual rocky planets are known to take in sunlight and emit infrared radiation. However, this is not the case for this planet, as its infrared spectrum is quite different from that of its host star Proxima Centauri. This is a great view from the James Webb Space Telescope, JWST, and the telescope is a useful tool for this. JWST can easily detect infrared wavelengths, and Proxima b's unique thermal signature will play an important role in unraveling the mysteries of the planet's atmosphere. This is the result of JWST's new capabilities in infrared imaging. Scientists plan to use this telescope to unravel the mystery surrounding Earth's atmosphere. They also plan to use the Webb telescope to investigate the possibility of habitation on this planet. The James Webb Telescope has the infrared sensitivity needed to see what's going on in the night sky of Proxima Centauri b. Picking up tiny rays of light in the dark universe is difficult for space telescopes. But for JWST, the smallest rays of light can be seen from space. This is a great tool to confirm if the reports of city lights on the night side of Proxima b are true or false. It is in a frequency band
the
1,000
Delta rocket
times
carrying
narrower than
blast,
starlight.
a gamma
How
ray
does Proxima
telescope
b compare
searching
to
for
Earth's
unseen
planets?
physics
Proxima
in the
b
stars
has a
of the
good
galaxy.
correlation between its stellar properties and surface interactions. The sun side of the exoplanet has many solar panels that use the star's energy. The edge of the spectrum also reflects incoming light rays. At the same time, as Proxima b completes its orbit around its host star, Proxima Centauri, it will experience the same day and night cycles as we do on Earth, increasing its temperature. Sunny during the day and cool evenings, this planet is known to vary in temperature due to its composition. For example, if Proxima b had no wind, the difference between day and night would be very large. Without the influence of the air and seas, the daytime heat would be too hot, like a black body, and the night side would fall into the coldest darkness. The sign of the temperature change is a good project for astronomers to gain a deeper understanding of the composition of Proxima's atmosphere. With its unmatched infrared imaging capabilities, JWST can directly monitor Earth's thermal emissions to provide insightful data on its atmospheric conditions. Interestingly, the Webb telescope's orbit around Earth coincides with the orbital period of Proxima b, and the best day and night observations are made within days. 11 in the world. Since it is still airy, the next step is to assess its atmospheric chemistry to determine if it can support life. Some good indicators to determine if there is life are the presence of gases such as oxygen, water vapor, and methane. If these elements are found on the planet, it means that they are supporting living conditions. The process to make a successful determination requires scientists to be very precise in capturing and analyzing the light rays moving through the atmosphere of the planet. Doing this is a very challenging task. While JWST has many capabilities for imaging planetary winds, it also has a primary mission. This telescope is specifically designed to analyze changes in water vapor, carbon dioxide, and methane gas. When it comes to detecting bound oxygen, an important indicator of life, JWST is very limited in this field. Even so, the telescope still has valid reasons to search for other elements on the planet. One of such reasons is ozone, which gives away an accurate level of vitality in the atmosphere. It's also worth noting that the James Webb Space Telescope doesn't have absolute capabilities and can only peer at a few of the closest habitable worlds to Earth, carrying out a thorough atmospheric investigation. Astronomers are now tilting toward ground-based observatories like the extremely large telescope YELT. The YELT is a telescope that has been scheduled to start operating in 2028, and it's carefully positioned to gaze deeper into the atmospheric structure of faraway exoplanets. It produces data on these planets that provide a comprehensive and clear view of their habitat levels that NASA scientists and everyone else are looking forward to the release of such wild-eyed telescopes. Until then, the James Webb Space Telescope will continue to be an important tool in our quest to unravel the mysteries of distant exoplanets. Despite its current limitations, the James Webb Telescope has the potential to provide deep insights that will revolutionize our understanding of exoplanet exploration now, and in the future. The scientists' goal for future telescopes is to reduce the amount of bright light coming from a planet star, so that astronomers can see it clearly. Light reflected from the planet itself. They plan to do this by using internal masks or gigantic external satellites that are shaped like an umbrella, similar to using your hand to block out rays of the sun to enable you to see an object clearer. In the bid to reduce the fierce brightness coming from the host star, future telescopes will be better positioned to study faint reflections of light coming from a distant exoplanet, allowing for a clear analysis of its atmosphere and likelihood of supporting life. Doing this comes with its own challenges. However, scientists will have to differentiate between gases generated from life and those generated from geological processes, such as volcanic activity. Astronomers aren't relenting in their bid to understand the characteristics of exoplanets, so they're more able to discover signs of life and distinguish them from false positives. The Webb telescope contains a preview of scientific advancements from the research of exoplanets, offering a sneak peek into the amazing discoveries we have yet to find. As we expand our knowledge and explore further into the universe, we have a better understanding of the inner workings of the universe and our role in it. After exploring all the planets in space, scientists have yet to find any planets that harbor life. Despite decades of searching places for signs of life, efforts to find life on other planets continue. Are we alone in the world? For millions of years throughout the human world, people have wondered if they were the only living beings on Earth. This is a very old longing that still hasn't left us in this present time. Even today, scientists have the James Webb Telescope in outer space trying to spot alien civilizations hidden amongst us while studying all kinds of planetary bodies for signs of life. At the same time, the narrative that some aliens are truly out there in the stars just waiting for humans to find them is indeed a popular narrative. To provide an answer to this question, two American astronomers, Jill Tarter and Thomas Pearson, started a project called the Search for Extraterrestrial Intelligence in 1984, known as the SETI Institute. This is a non-profit venture that plans to sift through cosmic signals to pick up only radio signals from space. Radio signals have the ability to travel long distances without getting scattered or absorbed like other types of radiation, hence their decision to focus on them. Due to this characteristic feature, radio signals are more likely to be detected by the 42 radio telescopes that constitute the Stellar Allen Telescope Array found in the Cascade Mountains of California. Though the SETI Institute has religiously observed signs of these radio signals generated by alien life, there haven't been any such signals for over 30 years. Jill Tarter is enthusiastic that they'll have a positive result, as they want to use the tools of the JWST and other powerful space observatories to search for planets that are friendly to human life. She remains hopeful that the great moment will eventually come when humans will find signals of life. Meanwhile, scientists explore their surroundings and discover new things along the way, hoping to find new clues in the years to come. As they continue their research and analysis, the world is waiting for the time when the James Webb Telescope will reveal the surprising truth about the world beyond the Earth. Until that day, we can only gaze in wonder at the stars and marvel at the possibility of life beyond our planet.